Alrighty. Questions from the homework. Actually, before you ask questions on the homework, number 5. Number 5 was wrong on the answer key because I never shifted it down. You might not even have noticed it. It was just a tangent, and it should have been like somewhere over here. I forgot exactly where. But I put it right there instead of shifting it down one. So there was a mistake there. All right. After saying that, what questions do we have from the homework? Shh. Yeah. Number 7. Do you have a specific question or?
It's shifted 3 pi over 2 to the right.
Yeah.
And then the period pi.
Yep.
We'll just show how to graph it.
Yeah. So let's get all those numbers. I'll go through this one. I won't go through any more. We'll just do the specific questions. So Aiden was pointing out that I should probably rewrite this. Remember that this is actually 1 over 2 times x. Right? So I need to pull out a 1/2 from everything. So that's going to be 1/2 x minus. And if you ever forget how to do this, remember when you distribute, it's multiplication. And so when you factor, it's division. All right, so when I factor out a 1/2, I'm dividing 1/2 by x over 2 and by 3 pi over 4. So that means to get that number to change, I'm going to do 3 pi over 4 divided by 1/2. What did you say the shift was? Did you say it was?
I got 3 pi over 2 to the right.
Because keep change flip would be 3 pi times 2 over 1, which would be 6 pi. Did I do something wrong on my answer key? It doesn't. It does kind of just stop. It just kind of does stop. Oh, that's what I did wrong. I know what's happening now. I just did 3 pi over, I see what I did. Because it was 3 pi over 4 divided by 1/2. I forgot the 4. I was like, that doesn't seem right. I never had 6 pi. So that'd be keep change flip. So I'd keep 3 pi over 4. I'd flip the 1/2 and it'd actually turn into 3 pi over 2. That's what you said you had?
Yeah.
I'm sorry I made you change it. Yes.
Wait, this was the bathroom?
Yes.
Okay, thank you.
Every day.
Yep, it always happens around this time. So
All right.
sorry.
So that means the period. The period is going to be, remember with cosecant, sine, cosine, cosecant is going to be 2 pi over b. So this will be 2 pi over 1/2. Did you say your period was 4 pi?
I got pi.
You got pi. It should be 4 pi. I think what you did is you just did 2 divided by 2 to get rid of it, but keep change flip, right? It'd be 2 pi times the inverse of that, so it'd be 2 pi times 2, so it equals 4 pi. All right, so if I count this out, I just want to make sure I didn't make any other stupid mistakes. All right, so I count out 4, 1, 2, 3, 4, 4 pi. We could do the half multiply by 2, so half of 4 pi is 2 pi. Half of 2 pi is 1 pi, and then it's just 3 pi, but it was just 1, 2, 3 pi. All right, so we're shifting 3 pi over 2. Now, is that the problem, the shifting 3 pi over 2 portion?
Yeah.
Okay. So it needs to go right 3 pi over 2. We can just approximate that. All right, and 3 pi over 2, well, 3 divided by 2 is 1.5. So 1.5 pi is going to be smack dab in the middle, right? So I'm going to move it over that far. And was I moving right? And I do believe this one goes off the graph a little bit. Yeah. Yeah, because if I had 1 pi, it'd be here. And then it would be way over here would be my other vertical thing. And so this one runs off the graph a little bit, but we just shifted those major points over those given points. Then I look at cosecant. Cosecant's going to be sine. Sine starts at 0, 0, so I shifted it over. I wouldn't have done this all in one step because it really does create some confusion. My amplitude is 1/2, so maybe I'll make this 1 and this -1, so it goes up 1/2, back down to 0, down 1/2. Back there, my vertical asymptotes were just the ones I made sure I had correct. And then I would go up and down and down. So I definitely wouldn't jump right here. I would have graphed it first, and then I would have then shifted, because then you wouldn't have to worry about figuring out where those points are going to be. Because as soon as you shift one a certain distance, then you know you're going to shift them all that same distance. Does that make sense? I know I kind of jumped to the end.
I had the period wrong, so then like the shift.
Was wrong.
Yeah.
Gotcha. Yep. But it's good otherwise?
Yep.
Awesome. Other questions? Yeah.
4.
4? Did you have a specific question? Because I just went through this whole thing. Oh, no. I went through this whole thing step by step, so I don't want to go through each one of these step by step. So I'd like a specific question, I guess.
I don't know, like finding the 2 different like parts.
For number 4?
Yeah.
You don't find 2 parts because it's cosine. It's just graphing cosine. It's not cotangent or tangent. What 2 parts did you mean, I guess?
It doesn't matter.
It does matter.
I just don't understand like how to do it.
Okay, so I'd rewrite it. First of all, that -2 is our down 2.
Yeah.
So I'd move that to the end. And I'd rewrite this as cosine. I'd pull out a pi over 4 of x minus 1. And then it's just -2. So my normal cosine graph, minus the period, you can worry about the period on your own. I'll call this 1 and -1. So you'd have to mark the period correctly. Alright, my amplitude is 1, so we're good there. It is shifted left 1 and down 2. So it'd be left however many units and down 2. And so it would just be shifted down here and come up. You just have to mark your period correctly. Okay?
Yeah, that makes sense.
Is that better?
I don't know, I couldn't figure out how to factor out the pi over 4.
Oh, the pi over 4. Always divide, right? I'm just dividing pi over 4 divided by pi over 4, which equals 1. All right, other questions? Yeah.
Can you label the x-axis for number 5?
For number 5? Yeah. Like, where are my 2 vertical asymptotes?
No, just the x-axis, like the period.
We're not going to mark the period because it's tangent.
Oh, okay.
For tangent, all we do is we find our left-hand vertical asymptote and our right-hand vertical asymptote. So my actual answer looked like, I should redraw this really quick. My actual answer looked like, this is all I marked. I said at -pi was a vertical asymptote. At -pi over 2 was a vertical asymptote. It got shifted down 1, and it was tangent, so it just looks something like this. Okay, yeah, so remember for tangent and cotangent, we're not going to mark all the points, it's just 2. It's just our vertical. Do you remember, does that help?
Yeah.
Okay, good. Otherwise, your life becomes really hard when you try marking them all, and then you try to figure out where your vertical asymptotes are. Just make your life easy. Just boom, boom, done. Other questions? Yeah. Jeff.
For number 4, when the phase shift is x minus 1, but you made it go over to the left, wouldn't it go over to the right?
It'd go over to the right. Yeah. It was just me rushing through. Thank you. Thank you for pointing that out, though. Yeah, it should definitely, with the negative, it should go right.
That was just for my own peace of mind.
No, you are 100% correct. I would hope more people saw that and just didn't say anything. Or were just not paying attention because they got it right. That happens sometimes. Okay, other questions? Okay. Now I'm going to get right into today's lesson, which is inverse. Inverses. Make sure if you didn't have this done, you get it done by tomorrow, because I'll probably check this homework tomorrow. I just don't have time today. All right, inverses of trig functions. We're going to start out with something that we did in algebra and algebra 2. We started with vertical line test. We had a vertical line test, and that told us whether something was a function or not. Because in order for something to be a function, each input can only have one distinct output, and that's what the vertical line was checking. So a graph must pass the vertical line in order to be a function. Well, let's just check all these graphs down here to see if they pass the vertical line test. To pass the vertical line test, a line can move through it and only hit one point at a time. So this passes the vertical line test. Our B passes the vertical line test, and our C passes the vertical line test, which is good because this is a sine or cosine. Those are supposed to be functions. This looks like either tangent or cotangent, which also has to be a function. So it should pass the vertical line test. The big thing is a graph of a function must pass the horizontal line test in order to have an inverse that is also a function. These types of functions are called invertible, where it is a function and its inverse is also a function. Well, if we look at A and we do a horizontal line test, works just like the vertical, except the horizontal. No matter what line I draw, it is going to pass a horizontal line test. On this one, I'm going to draw the vertical and the horizontal, saying that it's passing both of them. If I have a vertical line, it's just going to hit once. If I have a horizontal line, no matter where I put it, it's just going to hit once. Since it passes both of those, it is invertible. That means it's a function, and its inverse is a function. However, our next one, it does pass the vertical line test, but it doesn't pass the horizontal line test. So it is not invertible. Same thing with C. It could pass the vertical line test. No matter where I draw a vertical line, it's only going to hit once. But it will not pass the horizontal line test. Because it hits way more than one place. So this is also not invertible. And you're probably thinking, why is that important at all? Well, here's where the huge problem comes in. We're talking about inverses. According to the horizontal line test, sine, cosine, tangent, cotangent, cosecant, secant, they all don't have inverses because their inverse is not a function. In order for us to use it, it has to be a function. So I can plug something in and get a number out. Currently is not set up that way. So what we have to do is we have to limit our domain. We aren't going to cover this whole section. We're just going to reduce it to a little section that is both a function and invertible. All right, and I'll show you what that looks like on this next part here. So we're just going to condense what we look at in order to say, hey, this is invertible. So I'm going to first do my sine graph. This is 1, -1. I'm just going to draw a normal sine graph. Goes up to 1, back down to 0, back down to -1, back to 0. That's just sine of x. Not invertible. It is not invertible. What I'm also going to do, I'm going to add a little bit more to the negative side of it. Now currently it's not invertible because it doesn't pass the horizontal line test. However, if I just lopped off this stuff here, if I just went ahead and just chopped it right off, I'd be left with something that passes the vertical and the horizontal line test, all right, which makes it invertible. So in fact, that's exactly what we're going to do. We're going to lop off everything except for that one little section. So I'm going to say the only thing I care about is that little section when I take the inverse. So all I care about is that little section. Everything else I'm just going to forget about. But that changes my unit circle just a little bit. It changes it because I'm not using all 4 of my quadrants. Before, when I stretched from here to here, it made a complete circle. It was quadrant 1, quadrant 2, quadrant 3, quadrant 4. However, now we're just reduced to quadrant 4 and quadrant 1. So with sine inverse, or arc sine, as it's called, we're going to lop off this whole side of the unit circle. And we are just left with quadrant 1 and quadrant 4. So now let's draw the graph of sine inverse. To graph an inverse, all you do is to switch the x and y values. That's it. You just swap the x and y values and plot your new point. So let's go ahead and write down our x and y values for each of these key points. This one is pi over 2, comma 1. Then we have a point 0, 0. Then we have negative pi over 2, negative 1. And we just swap our x and y values and plot the new points on our inverse graph. So rather than being pi over 2, 1, we're going to make that 1 pi over 2, which is right here. So once again, all I did is I flipped my x and y values, and then I brought it over here. 0, 0 flips to 0, 0, so it just stays 0, 0. And our final one is negative pi over 2, negative 1, so it's going to be negative 1, negative pi over 2. Since it starts off concave up between negative pi over 2 and 0, we're going to start concave down. We're going to start concave down. And over here from 0 to pi over 2 is concave down, so this is going to be concave up. You are not going to be asked to show me these steps. But what you need to know is you have to know the graph of sine inverse. All right, so on the test, I can just say graph sine inverse of x, and you have to reproduce this. In fact, that will be on the test. All right, either this or cosine inverse or both will be on there. So you are responsible for being able to reproduce this. There will be no transformations. All right, there's no amplitude. There's no shift left or right or up or down. It is just this. Anytime I ask you to graph an inverse, it's just going to be this for sine. And then you also have to remember that sine inverse only lives in quadrant 1 and 4. All right, now let's talk about what sine inverse is and how we calculate it. Oh, I should also note that, so we live in quadrants 1 and 4. I said it, I just didn't write it. Now, first of all, I want to talk about the fact that I will say sine inverse and arc sine interchangeably. Yeah, Nick.
Can you go back to that? I don't get how, like, that's 1 and 4 is. Doesn't it go through 1 and 3?
1 and 3.
Like the 2 parts of it.
Well, let's just highlight really quick. So this is quadrant 1. Let's change my color. This is quadrant 2. This is quadrant 3. And what color didn't I use? This is quadrant 4.
Oh, so that shape.
So that has to be quadrant 4. Has to be. Yep. So it's 1, 2, 3, 4. Okay. Now I'm going to use the words arc sine and sine inverse interchangeably because they mean the exact same thing. They're not even subtly different. They are the exact same thing. So if I ask for the arc sine of something, it is the same thing as saying sine inverse of something. All right, up until now, when we used our unit circle, I gave you an angle. All right, my example here was find the sine of pi over 4. So you went to your unit circle and found pi over 4 and found your y value, and that was your answer, right? Because we have an x and y value. You found your y value, and that was your answer. Inverse is going to go the completely opposite direction. I am going to give you a value, and you have to tell me what angle gives you that value. So my example here was sine inverse of square root of 2 over 2. I want you to take out your unit circle. Take out your unit circle. And I want you to find where sine actually equals square root of 2 over 2. So where is your sine value square root of 2 over 2? Anywhere else? 3 pi over 4 and pi over 4 are 2 possible answers, right? We can only list one answer. You can't list 2 answers. Just like, remember when we did the cosine squared, sine squared equals 1? Where you only could do one answer even though it's positive or negative, you got to pick one. Only one of those answers is the correct one. So on sine we have 2 possible values. We have one in quadrant 1 and one in quadrant 2. Sine inverse does not exist in quadrant 2. That's why our answer is only pi over 4. All right, we're always going to pick one of the answers, and it has to be the one that's in quadrant 1 or quadrant 4. All right, that's the hardest part about inverses. All right, so we start outside with inverses, and we give an answer that's in an angle. So our first one is sine inverse of 1/2. So I want you to locate 1/2 on your unit circle for your sine value. And then I want someone to raise your hand and give me what is the actual angle. What is our answer for this one? Nick?
30 degrees.
30 degrees or?
Or 150.
But 150 can't work, right?
No. Because it has to be 1 and 4.
Yep. So 150 can't work. So it's either 30 degrees, in other words, pi over 6. 150 cannot work because it's not in the 2 quadrants that exist. 1 and 4. All right, someone tell me, what is the arc sine? Remember, arc sine just means sine inverse of negative square root of 2 over 2. David?
315 degrees or 7 pi over 4.
7 pi over 4. I'm just going to stick with radians. All right, listen on the next one. I'm doing sine inverse of square root of 3 over 2. I want someone to give me the wrong value. All right, you're going to get 2 values. Someone give me the wrong value and tell me why it's the wrong value. Okay?
2 pi over 3.
And why is 2 pi over 3 wrong?
Because it's not in 1 or 4.
Because it's not in 1 or 4. So what's our correct answer?
Pi over 3.
Pi over 3. So just be aware you're going to get 2 answers. Only one is the correct one. All right, we're going to do the exact same thing for cosine. If I draw a regular cosine graph, we start at 0, 1. We come down to 0. We go to negative 1. Come back up, and we go up to 1. Once again, this graph is not invertible. It is not invertible because it doesn't pass our horizontal line test. So we're just going to limit it. We're going to say, okay, if you don't work, I'll push you in a box and we'll make it work. So we are going to put part of it in a box, and we're going to put this section in the box. And that is going to be quadrant 1 and quadrant 2. So cosine's only going to exist in quadrant 1 and quadrant 2. So maybe I'll write that here. Cosine inverse exists in this quadrant. I'm going to go ahead and graph it. Once again, to graph it, you just got to swap your x and y values out. Juan?
If you did quadrant 3 and quadrant 4, wouldn't it also work?
It would, but the standard is to take these two. It is possible, but like book answers and what your calculator will spit out, it will just focus on 1 and 2. So you have to do what the traditional thing is. Because as soon as every math book and every person agrees that this is the one we reduce it to, then when I give you an answer, you know it's from these two quadrants. You would have to specify that you redefined it as 3 and 4 and changed the whole kind of system. All right. So yes, you're 100% right that you could do this, but it's not standardized, so you have to do the quadrant 1 and 2. Have to. Because you don't want to explain yourself every single time you give an answer. All right, so I'm just going to list my x and y values. So this is going to be pi, negative 1. I flip that, and over here out of negative 1 pi. My next point is pi over 2, 0. So that means on my inverse is going to be 0 pi over 2. And finally, we have 0, 1. And so our inverse is going to be 1, 0. Ba, 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 ba. The real hard part is, well, this is concave down. So my first bit's going to be concave up. My second part is concave down, so concave up, so this one's going to be concave down. It's going to look just like that. Once again, I'm not expecting you to have to circle this and then draw this. All I'm going to say on the test is, give me the graph of arc cosine x. No transformations. So those are two probable questions on the test. At least one of them will be for sure on the test. Probably both of them will be. I'll probably ask you to graph the sine inverse and the cosine inverse. If you have these two memorized, that is 2 problems done. So we are reduced to quadrants 1 and 2. Once again, we just go to our unit circle. This time we're looking for cosine values, so we're looking for the x value. So I'm figuring out where x value equals 1/2. And I want to figure out what angle gives me that. So let's all look at our unit circles. If you don't have your unit circle on your desk, you're doing something wrong. Because you should at least be turning to it and looking at it. So what's my cosine inverse of 1/2? Make sure it's in quadrant 1 or quadrant 2. David? What was that? Pi over 3. Do we all agree with pi over 3? Check it. Don't just assume it's right. Okay, what's our cosine of negative square root of 2 over 2? Okay.
3 pi over 4.
3 pi over 4. Arc cosine of 1. Jack? It is 0. It is okay if it's on the line. Because a lot of people say, it's not in quadrant 1 or 2 because it's right on the line. That is okay. Because these points exist. All right, these are the ends of our unit circle. Those are okay. As soon as you go into another quadrant, then you can't do it. So 0 is 100% fine, or 0 degrees. All right, real quick recap. Things we need to know. We need to know how to graph those sine inverse and cosine inverse. The next thing we need to know is how to actually calculate those inverse using the unit circle. In order to do that, we have to know what quadrant each thing's in. So I always just write it out this way. I write cosine. I just write cosine. Because that's going to tell me neither of you is quadrant 3. Cosine lives in 1 and 2. And sine inverse lives in 1 and 4. So if you just remember cosine, and you do that on your test right before you start off, you know what quadrant everything's in. Just remember that if you're ever taking the sine inverse or cosine inverse, your answer will always be a degree or a radian. So it will be an angle. So sine inverse or cosine inverse will always result in an angle. And you might be telling me right now, duh, we just did that. We found a value out here and we give the angle. I guarantee on the test, several of you will put like, the sine inverse of square root of 2 over 2 is square root of 2 over 2. You'll just like repeat what it is. Alright, so anytime you see sine inverse, arc sine, cosine inverse, either you're going to give an answer in degrees or you're going to give an answer in radians. Alright, it's either going to be pi or it's going to have degrees attached to it. Alright, what I want you to do is I want you to do these next 4 problems. I want you to do them as in your pods. So you should all be working and talking and make sure all 4 of these are the exact same within your pod. Okay, we got to move on. Someone in Kate's group, anyone in the pod, give me what cosine of 3 pi over 4 is. Negative radical 2 over 2. Thank you. Someone in Juan's group, tell me what is the cosine inverse of negative square root of 2 over 2?
3 pi over 4.
3 pi over 4, yeah. It just goes one way and then comes right back. All right, someone in Jack's group, what is sine of 7 pi over 6? Negative 1/2. All right, last pod. What is the arc sine of negative 1/2?
11 pi over 6.
11 pi over 6.
You just put sine, like this one.
Okay,
You just
we just have one more thing to do.
use that you find angles.
On to the next thing. I'm only going to do one of them. Where are we? We're here. I'm only just because people struggled on the homework for this. All right. I'm supposed to find the sine alpha equals 0.88. I'm supposed to find alpha. I'm going to use degree mode. And we know to use degree mode because I told you to use degree mode. It's the only way you're going to know. All right, we're going to use degree mode. Now, I need to get alpha all by itself. Which means I need to get rid of that sine. I need to get rid of that sine that's right there. To get rid of sine, don't do this. Someone's going to on the test. I almost guarantee it. They almost do it every single year. It seems funny, but someone's going to do it. I never talked about multiplication. This undoes multiplication. This isn't sine times alpha. This is sine of alpha. To undo something, you must do the inverse. Yeah, if it's multiplication, the inverse of multiplication is division. The inverse of sine is just sine inverse. So you're going to take the sine inverse of both sides. And how that's going to look is just like this. So I take sine inverse of sine alpha. But what I do to one side, I must do to the other side. So I'm going to take the sine inverse of the other side. Sine inverse and sine cancel each other out. They turn to 1. And so you're just left with alpha on this side. And alpha is going to equal sine inverse of 0.88. If you plug that in your calculator, you're going to come up with alpha equals about 61.64 degrees. If you didn't come up with that, your calculator's probably in radian mode.